Hey, what's up, fellow YouTube? Today we're gonna create a double deck in Java, and basically it's a double-ended queue. So we just pronounce it double deck. And the way you do that is you basically have a linked list that is going to um, add items at the end and add items at the front, and then you can navigate the queue either way. So let's go ahead and create that. And the first thing we want to do is open up our command line. So I store all my projects in deb. So let's go to deb and let's create a directory for it. And from there, after we create it, we need to navigate into it. So let's go ahead and do that. And let's go ahead and open up Visual Studio Code here. So once we do that, let's go ahead and close the welcome page and let's add a file that we call double deque Java. And we're gonna create the main right in it so we don't have to worry about writing tests. So I'm not going to create tests today. What I do want to do is just send the output to the screen, and that'll be enough for our testing. But maybe, perhaps later, if you leave a comment below, maybe I'll do a test session where you can see the actual testing, how I can actually write unit tests for it. But for now, let's just go ahead and start by creating our class. So public class. And let's create a main right in here. So let's go ahead and create it. So that's the beginning. And let's go ahead and do a system.out print line, and just the hello world to make sure we can compile. We can go ahead and save that. Let's go ahead and view the terminal. Let's go ahead and view terminal, and let's go ahead and compile this. And it compiles. Let's go ahead and run it. Can I find double deque? Okay, I think it's because, and it says hello world. So the way a double deque works is that what you have is, let's just say that we had a list, and it's like really behaves like a doubly linked list, and we can have the front and the back, and as you know, most of them we have nodes. So let's say we start off with our empty queue, and then we add something in. So we can have methods like add front, add back, and then we can remove from front and remove from back. One thing that you should always have in anything that has a list or any kind of collection, you want to make sure that we can check if it's empty. And the idea with add front is that, for example, let's say we had a queue and we had some value that we wanted to add to it. So let's say we add 1, but we have to choose if we add it to the front or to the back. So if we add it to the front and it's empty, well, we initially just have 1. Later on, we come back and we say we want to add to the front, and we add again. Now we add another value. We add 2, for example. So we would add, we would already have 1. We go to the front and we add 2 to the front. If we were to add to the front again, we would add, we would have 2 and 1, and we would add 3 to the front. Now, if we wanted to add to the back, and since we already have 3, 2, and 1, we would add to the back, and we would add 4 to the back. And we add it from the back, and it just keeps growing. So when we remove anything from it, if we actually remove from front, it's going to remove 3 first. If we remove from front again, it'll remove 2. Remove from front will remove 1, and remove front will remove 4 eventually. Or you can remove everything from the back. Remove from the back would remove 4. If you remove from the back again, it would remove 1, and so on. So, and the idea that you can see is that double deck queue is because it can go in both directions. We can use it as a queue, or we can use it as a stack as well, because if you think about it, if we add to the front and we remove from the front, we could use it as a stack. For example, in this example, where we added 1 to the front, and then we added 2, and then we added 3, well, we could start removing from front, and guess what? We have a stack. We can remove 3 and 2 and 1. So let's go ahead and start writing this. And one thing we want to do is we want to make sure that we make it where it's generic, using generics, because we want to be able to reuse our queue with different types. So one of the things that we want to do is, first thing, anything with that requires a linked list, you always need a node. You need some kind of node definition. So we create a private class node, and node can have data of type T. And we have our data, and our data could really be anything. And then we can actually make it where we don't need any accessors. So let's just make them public, or we can make them private. It doesn't matter at this point. And since we're just storing data, there's no need to create getters and setters. So we have the node, and now what we need is, since we're pointing to next and previous, we need to have another type node, another node here, and we can call this next. And we can have another node and call it previous. And like Robert Martin says, don't abbreviate unless you need to abbreviate. So I prefer to use previous, the whole word, as opposed to the abbreviation prev or anything like that. So it's just best to use the entire word. So once we do that, we have a node now, and as you notice, we're using T. Since the class is T, whatever type we define is going to be. So we can use integer. We can use integers, doubles, whatever, strings. We could also use full objects. One of the things about this, though, is that we should probably have a constructor. So let's create 2 constructors. One. And we can set data equals null. And we can say next equals null. And previous equals null. And you may be wondering at this point, well, if we use it with ints, how can we know that we can set it to null? Because, for example, if we use int instead of integer, well, the thing is with Java, you can't do generics on primitive types. For example, I can't do it on int, but they do have the object version or the class version of those types where you have the integer and double and so on. So that's what these generics work on. So they deal with boxing and unboxing. So if you don't know what boxing and unboxing are, basically it just converts from the object type over to the integer type and so on. So you can actually store integers in it. It's just that it'll be a reference to an object, and they can actually be null. So the first thing we'll want to do is we'll want to write it's empty. So one of the things is that if we create a public void, it's empty, we have to return some kind of Boolean condition. So we would return what? At this point, we need something that tells us maybe our size. So that's one thing that I left out, and we probably should track that. Since Java uses size for most of its collections, size is a good name for it. So let's go ahead and keep track of size, and we'll create it as a private integer type, and we'll just name it size. And we can have a constructor for this. Sometimes you want to empty your queues though, so let's go ahead and create another method that's called clear. And the clear will empty the size out, so let's go ahead and write that method. And clear will simply clear the size, so then we can say size equals 0. And there's other things that we need to do, so we can add a to-do statement here. Say clear the references to the nodes. But since you notice that we have add front and add back, we're going to need something called back and front. So we can create these as nodes, and we'll call this back. And front. And so the other thing that we want to do here when we clear is we'll want to set front and back. And we'll clear them. And you notice that I didn't delete any memory or anything. If you're coming from C++, you may be used to saying things like delete front, delete back, and or navigate through all the nodes and delete them. There's no need for that because Java has automatic garbage collection, so the garbage will be collected as soon as there's no references. Well, when it decides that it's time to clean up, but once you don't have any references, then it's cleared out. So all you have to do is say front equals, this basically just says front equals back equals null. Basically, you assign null to back, then this becomes null, and then that null also gets assigned to front. So that's all we have to do for that. Now to check is empty, we can simply return if the size is greater than 0. If the size is greater than 0, that means that it actually has something. So we need the inverse of that. So instead of saying greater than 0, we can just simply say size equals 0, and then we know that it's empty. One mistake I made here is that this should be a Boolean, not a void. And that basically returns a Boolean value that says, yes, it is empty. So another thing that we may need to do is that at some point we may want to iterate through our collection without clearing it out, because remember that these add front, add back, they add something to it. Remove front and remove back will actually remove something from it. But what if you want to see what's actually in it? There should be some kind of way to see what's in it. What we can do in terms of that is maybe give you an entire list. There's different ways of doing it. There's the iterable interface and the iterator interface. For now, let's do something just very simple where we actually give you all the values stored in it. So we can add another one that says get all, like this. And so let's start with that. Let's see. So we have only a implemented that is empty. So let's go ahead and implement the add front. And since we're adding and we don't know the type, we just say T and we say data. And at that point, we can actually check if our size is 0. If our size is 0, then we know that we have a null head and or a null front and a null back. So we can simply say data actually, front equals new node, and we pass in the data since we can. Oh, and that's one thing I forgot. We need to create a constructor that has a constructor to initialize this with the data, and it also be data t. And we can simply at this point data. We assign data to data, and next equals null, and previous equals null. And so when we add to the front, we create a node, and we're already pointing the front to the node, so we now have to point the back also to the node, to the same node. So they're pointing to the same exact thing. So they're both pointing to the front in the node. If we take a look, if we did something like this, don't think of it as like assigning the actual value, because what these are, even though there's no pointers in Java, types, like I said, anything with generics is going to be an actual class type, an actual reference type. So if you think about it like this, let's go ahead and open up Paint. And if we take Paint, for example, when we think of front and back, if we have front here and we have back here, initially they're both pointing to null. They're both pointing to null. So they're both null. Once we add something, we actually create a node. We create a node, and we have a node that should have front and back. And it's an actual node, and let's see if I can do this. It's an actual node. Just put a kind of a line there. And so data is in the middle here, whatever that data happens to be. And this will be the previous, and this will be the next. And these will be pointing to something in these directions. But now since we added an item, this kind of goes away. This area here goes away, and we actually start pointing the node here to this one. And it doesn't matter if I'm pointed here or whatever. So let me, as a matter of fact, just point it with the pencil. We're pointing to this node, the whole node. And this node, this back is also pointing to this node. So they're now both pointing to the same node. So if I wanted to access the front, I can come through this node and it'll show me what's at the front. If I want to access the back, it'll go here and it'll point me to this node. They both point to the same data, and this is actually pointing to null. If I add another node, which I can add another node. So if I add another node, what would happen is, it depends where I insert it from. If I go add it to the back, well, what I need to do is get rid of this connection. Get rid of this connection. And I'm adding it to the back. So now the back will actually point to this node. So it'll point to this node, and now this node, the next has to this node here, the back would have to point here, right? So I'm pointing the back to here, but that last node, this node now has a previous and a next that it's pointing to. So the previous is going to point here. And its next, well, there's nothing after it, so the next points to null. And so we can navigate this list by starting from the head, and if we go here, the other thing that has to happen here is that this previous node must also point to this node has to point to this node. So they're connected. So now what happens is that if I want to navigate from the front, I can start from the front, grab this one, go to next, and it points to this, and then eventually I get to the end. If I decide to start from the back, I start from here, I find my back and it's here. I go to previous and it lands me here. If I go to previous from there, well, this previous points to null because it's not pointing to anything. And it'll just keep growing like that. Hopefully that makes sense. If you think about it, it'll just be something like having you have the front here and you have the back, right? With so many potential in-betweens, and we're just adding nodes. If we add from the front, we add a node here. If we add from the front again, this is going to kind of squeeze to the right. And then we add another node here. Oops. We add another node here. And these always, since they're doubly linked, they're always pointing to each other. If I was to add from the back, it would add it here. And what we have is this node points here. And of course, this node doesn't point to anything. This one being the head. And then this one is going to point back at this one. And let me use the pencil because it's easier. It's going to point back at this one, but this one has to also point to this one. And this one's going to point back to this one. And this one points to this one. And this points here. And this can't point anything, so it just points out into null. So the first node and the last node always point out to null. They point out to nothing. So just, they point out to nothing. First and the last don't point out to nothing. The actual front points to the first node, the back points to the last node, and these don't point out to, the first node doesn't point, the previous doesn't point to anything, and the last one next doesn't point out to anything. So hopefully that makes sense. Let's close this out. So there it is when we add the front. So we do that, but that's only if the size is 0. If the size is 0, we add it to the front. But what if we actually have something in here? So if we don't, we can execute an else. And one of the things we have to do is that we still have to create a new node. So we can say, we just call it node. And for lack of better terms, we'll call it a temp. And we'll say new node, data. And now the new node, the temp, and we'll say temp.next, is going to be pointing to the actual front. So we point to the front. And at that point, the front now has to change its position because the front is no longer at the pointing to the front because the new node is what's actually the front. So what we have to do is point our front to the temp. And we're always adding at the front here. So that kind of takes care of adding to the front. The other thing we have to do, no matter what, if we added it here or here, it doesn't matter. We have to increment our size. We just increment it by 1. Our size grows by 1. So now we have to do the same thing to the back. When we add to the back, it's going to be very similar. If the size is 0, we say, we can actually say front equals back. We can still do the same thing. It's not going to change anything. It doesn't really change anything because the front and the back have to point to the same thing. So this is okay. But just for simplicity, we'll say back equals new node, and then we'll say front equals back to be consistent. Now, if the back is not there, what we have to do is create a new node, temp, and now temp, instead of temp next, it's going to be temp previous. equals back. And then the back now becomes that temp. So we've added to the front and the back. Just that simple. Very similar to adding to the front, and the size grows again. So we've knocked that out. And so what if we want to remove from the front? So, and one thing that I left out here is that I actually need to have return types for add front and add back. And we're probably going to have errors once we compile for the first time, but that's okay. We can fix errors. So let's say now for removing, it's a little bit different because we have to return the data type, which is T. We don't know what it is. It could be anything. And we say remove front. And so at this point, we can take and say, okay, well, we need to find our front. We know what our front is, so we need the temporary location for our front, right? So we can say temp, not actually temp, node, temp equals front. And then we can take and move the front forward. So we can say front equals front next. So that's assuming that we have something, that we actually have a front. So we have to wrap this up in an if statement. If size is greater than 0, then we can perform that operation. We can perform this operation. And the reason that we need to save the temp is because we have to return the actual temp data. So we need the data. And you notice we're not returning the node. That's because we want to hide those implementation details. We don't want our users to be concerned with actual nodes. So this is giving me an error because we're only assuming that we have if it's something greater than 0. Now here, we may actually want to know, throw an exception because we don't want to mislead anyone into believing that they have something. So we can throw an exception. We'll say runtime. We'll throw a new runtime exception. We'll just throw that exception. And this makes our code compile. Now the remove front is very similar, right? But what do we forget here? Well, one of the things is that we're tracking our size, and only if they actually remove something do we want to decrease the size. But so before we actually remove it, and that's the reason that we can't just return front. So we need to say size minus minus, and that decrements the size. So to remove from the back is going to be very similar. But here's the thing. If we remove from the front next here, let's change this so we can get rid of the red. The thing about this is that we remove from the front, we have the front points equal to next, but remember, front was pointing, front next was pointing potentially to something, right? The front, actually the front doesn't point to anything, but what about front next? It was pointing back to the temp. So what we want to do is now front previous, we want to make sure that it doesn't point to anything. So we say front previous equals null. We don't want it to point to anything. We want to remove that connection, and then that node, that temp, is no longer being referenced by anything. It can be removed, and when we just return the data, and at that point it just goes away once the garbage gets collected. So let's copy that logic onto remove, it's not remove add, but remove back. What we do is we find the back, and now back is going to be equal to back previous. Remember, we're going the other direction. So back is now pointing to the previous, and same thing with back. Next, now this time it should be next, should be equal to null, and it's equal to null and size minus minus, and then we return the temp data. So we've added the add back, add front, remove back. We've done is empty. We need to be able to expose the size, though. We haven't exposed that, and that's because whoever's looking at this will need to know if the size is actually, well, actually we expose is empty. We could take and expose the size. Sure, why not? Do we need to? Probably not. But we could. I think it would be handy. So let's go ahead and create that method. So let's go ahead and create the method size. And we can just return. And so it returns the size. Hopefully this won't give us a problem. If it does, we may have to change the variable name of size. So we have the size, and we also already implemented the clear. So we know it'll clear. So we have that. And we need now to implement the get all. So let's go ahead and implement the get all. And the way we can do that, and what we actually need is an array of type T, and we'll call it get all. And let's declare an array. And so here we run into an issue because we have to know the size, but we do know the size, so we can say type T equals new T of size, and we can actually give it the size, and let's see if it lets us get away with it. I think it will. It might not. Insert dot class to complete expression. Let's see if Java syntax error. Insert dot to complete expression. I'm not even sure what that means. So we have a sort of an issue here, but it's okay. We can, and this is what I normally do when I actually code. And you should probably too, or maybe not as much as me. I've worked with a lot of different languages, so I think that it would be a good idea at this point to go ahead and open up Google. And I'm not even going to look up that error. Well, I can look it up, but I think I need to say how to create generic array, or create array of T in Java. Let's see if that comes up. So Stack Overflow is very handy. If you don't use it, I'm not sure what you're doing, but it's very handy. So like if you notice here, they have an array. Oh, okay. So they're trying to do it that way. They're trying to declare an array of E, and it says, due to the implementation of Java, you can't have code like this. And then somebody will come in and say, well, here's how you do it. Okay, so this guy says, okay, so he's saying he's creating an array of it here. And he's creating a final suppress warning unchecked array new instance CNS. So I assume that's the correct way of doing it, and it says uncheck. So he's doing it where it's checked here, and this is a weak way, which is where you actually create a new array. Of just object, and then you actually cast it, because you can do an array of object and then cast it to type E. So we could do that. So one way to do it would be to say, to do it unchecked and do it that way. Okay, so which one do we want to do checked? Okay, so why does this have class E, C? So we can do it simply like this. Why does it need C? Because we need the class E. So I think that's what that meant. So I think what that means is that we have to say something like that. So we have to say, we can actually say object and then whatever type. Let me see that. So why wasn't I able to say T like this? Oh, because I need a variable. Okay. That's what I needed. I didn't even need to do all that research. Isn't that funny? So now I have my array. So now what we can do is navigate, and the way you typically navigate a list is using the while loop. But since in this case we really do know where what our size is, we can simply use a for loop. And well, we need to know where the first node is. So we'll say node current equals front, just like that. And then we could say, so we're already at the front, okay? And we need to add that to the array. So we need to add first of all, the thing about it is that if the size is 0, we probably just return, we could simply return null. So say if size equals 0, let's return null. And I believe that's perfectly valid. So now that we have that out of the way, we know that the front is there, so we can actually say we can simply say my array zero, we start with 0 here, is equal to front dot data. We pass the data into it. So what that means is since we already did 0, we need to initialize this to 1 and start from 1 instead. And so now we can say my array 1 equals current dot data. But before we do that, we have to navigate the current equals current dot next. Because remember, we already did the front, and right now current is at the front. So at this point, we can do that, add to the array, and then we simply add the array. So then we can just return the array. And like I said earlier, I'm violating one of the principles. I could just say temp array here and actually use the full word. And here we can change this to temp array. And here we can say temp array. And so that's how we get all. We get everything in the array. So now we have everything that we set out to create. So let's go ahead and test it out. One of the first things that I want to do to test it out is I want to see what's in there at all times. So let's go ahead and print our double deck. So we'll just say public for now, static void print, and we'll just call it print. And it'll accept the parameter of double deck t, and we'll say double deck. And what we want to do here is just have t here. Does it care? Let's see. Let's do it that way. It doesn't like t because it doesn't really know what t is in this context since it's a static. Cannot make a static reference to the non-static t. And I think in order to do static functions, let me see how to write a static function, a static generic function in Java. So let's see what this comes up with. Static generic method in Java. So let's see, that might not be what I'm looking for. Oh, so you got to tell it on the other side, public static nv. Okay, so I think we got it. I think so what we need to do, static t like this, and then that goes away. And the reason for that is because since it's not part of the class, we couldn't use it. So we have to tell this static method, here's what our type is, and here's how we do it. So now all I have to do is, since I can get all, I can say for t data in, and then we say double deck dot get all. And it seems like it doesn't seem to acknowledge my type. Let's see. Syntax on token double deck, delete this token. Oh, that's because I'm mixing languages here. So now that I have that, I can print out my data. So system.out.print line, and we'll just go ahead and print it out, and we'll print out data, and we assume that it has some string type. So let's go ahead and create a double deck here. And let's create a few methods. Let's create a method to test if it prints out a list of 5. So let's create a public static void. So we'll just call it test the first just initial test. or we could call it test one for lack of better names. And we'll say double deck. We'll declare a double deck. And we'll call it DD equals new double deck. And we have to actually tell it the type. So let's test it with just integers. And in Java, like I said, you can't use primitive. So we say new double deck. And we can leave this open, this part open. And I can say, in this case, print. Well, actually, before we print, we're going to add front. And we're going to add a 5. We don't need a string. We add a 5. And then we're going to add front again. Now, keep in mind, it's going to keep pushing them back. And you'll see what I'm saying about this. So if we keep adding front, it's going to push everything to the back. So 5 gets pushed back, and then the 4 goes in front of it. And now I'm going to do 3, and so now it's 3, 4, 5 in that order. And then we add front, and we add, let's say, 2, and let's add one more. And let's do 1. And so in this case, instead of calling it test 1, let's say test add front. See if it's adding them correctly. So in this case, then I can just say simply print, and I pass in my double deck. And let's test, and then here instead of hello world, we can just replace this with test add front. And let's see if it executes that, or if we get errors. So let's save that. Let's go ahead and run our command to compile. And we have a few errors. Let's see. Cannot find symbol temp prep back. So 55. It tells us that the Java line is 55. So let's go ahead and go to line 55. What symbol? It's saying, oh, violating my rules. It should be previous. Not sure why I did that there. Temp equals node. Okay. Remove front. Did it somewhere else? Okay, looks like, okay, my array in line 106 is also an error. So it should be temp array. And let's see. Okay, let's save it. Let's go ahead and recompile. Oh. Somehow we are missing. Okay, this points to line 73. So I think I found the issue. I think the issue is that when we removed here and we pointed front to next, we could actually be at the tail, and we're trying to set previous to something that it's not. So that's why it's airing out on the last item. So if we can say if front after we assign it not equal to null. And these are the kinds of problems that you run into with any kind of linked list. You always have to make sure that when you change something, advance the reference, that you actually change it to where it's check for null, because we changed it here. Well, front could possibly not have anything and it's pointing to null now. So at that point, if front is not null, that's when we have to come in and say, well, you know, we can't change previous. And the same thing's going to happen in the back. So And I changed this to data because it was simply easier to just get the data. But at that point, the that reference from front, that's everything's fine there at that point. But we have to do the same thing here. So let's just change this instead to t equals back dot data. And back is not equal to previous, but we also have to, we're going to have to do the same check here. If back not equal to null, in other words, if we actually have a node there, then we need to update this. And we're always going to remove this, and temp is now the data, so we just have to return the data. So let's go ahead and give that a try again. Let's go ahead and run it. And now it prints all of this, but now you notice that the error now has moved to line 125. So we have another error in line 125, and that's probably because line 125, we don't have anything for the queue. So we're saying we're returning null, but we don't have anything. And so that's a problem there with all, that we probably have to determine that if it's actually, we can actually have an array of t, and this will give us into the problem of t all equals and it gets us into trouble. But we can say actually if all not equal null, and I'll see if this compiles because this may actually give us issues since we're using arrays again. Let's go ahead and recompile it. Let's clear it and recompile. So let's go ahead and recompile our Java. Let's go ahead and run it. And now you see it does that, but it doesn't print. So the adding to front there, so we added to front, it printed that, and then we are going to add the items back again so we can print them. And now it should print them. So, and maybe we should put a system.out print line here for this test. Just like that. Let's go ahead and save it. Let's go ahead and run it. Oops. Did something wrong in my print here. I believe that's it. And now we can actually see where it's actually printing things out and adding them. And this was kind of funny though, because it actually printed our adding this time. So why is that? Because our print doesn't have the adding. So why does it print one before the other? Oh, it printed them down here. So what are these then? We're printing the adding, so we're going to remove the adding because we don't need that. But we do have the print test at front when we add them. And then we print them, and then we print them again. So here we're printing the data, and that's basically this guy here because we don't have a line. We're printing the data. We could actually print data plus like this to show a space in between. And this one, we could do the same thing. print remove front plus like that. And so we can save it all. And let's go ahead and recompile it just to be at a good starting point. And notice it printed it twice. So we probably want to have a print line in between these, in between this print and this print. So let's go ahead and add, let's see, test that front and just before print. Print line. That we can see the two things in separate lines. Oh, I keep forgetting my semicolon. Not sure why. Okay, so let's go ahead and rerun it. And you see the two lines, so they print it. So that's just testing at front. So that means we'd have to add for testing at back, and we could do the same exact test. We could say test add back. And did I change the name? Yeah, test add back. And we'll test add back. And we just change all of these to add back. But one of the things about add back, it's going to add to the back, and then it's going to add back. So we probably want to have them in the other order, where we have 1 and 2 and 3 and 4 and 5. That way it stays in order, and that way we can actually verify it. So we could do the same thing, 1 and 2, because remember that it's going to push them back, so we want to have them in reverse order. So we have 5, and now it should do basically, it's going to look the same way. You're not going to see a big difference, but it's because 1 goes in and then 2 goes in front of that. So it's going to be like something like this. Basically, you start off, you add 1, you add another one to the back, which is 2, and then it's going to add 3 to the back and 5 to the back, 4 to the back, and 5 to the back. Now, if you wanted to, as you're adding items, you're adding them in the back because it's a queue, but you would remove them from the front. So you every time, you know, like when you get in the back of the line, you get in the back of the line, everyone gets in the back of the line, but they get processed from the front, so we would have to remove front. So they're going to get processed in the order of remove front, in the order that they went in. And then we can actually see, if we do this, that we're going to have the numbers in the right sequence. So go ahead and run that. So we have test add front, test add front. Okay, well, we should have had test add back. So why didn't we have? Oh, because we didn't call it. We have to call our function. So we go ahead and run it. And now you can see the test add back. And we probably need a new line in test add back here. But you can see that it did the same exact thing. So now we know if we're adding to the front or we're adding to the back, that it actually adds in the right order. And you could switch from those. You can now see that you can add them all to the back, and then, you know, actually here when we tested add back, it printed it backwards because we didn't test it adding everything to the front. And you could do combinations of them, so test add both or whatever. But I'll leave it up to you to take it to the next next level there, because this video's already run kind of long, and I know sometimes some of you guys don't like long videos. So I'll leave it up to you, and maybe post a comment and let me know if you want to see more of this. Of not I'm not talking about more of this type of thing, but more of this. If you want to see me take this a little bit further, then I can. I'm going to post a link to the code below, so that you can test it and run it yourself. But that's essentially the 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 double deck queue or double deck. And you notice, like I said, a couple of important things. We use generic so that we can use any data type. That's one thing that we didn't test here. We could actually test it with other types. And that would be as simple as saying, like, for example, here, if we say we copy some of this, let's go ahead and copy that. We'll say we'll test it with strings. And that's the whole beauty of generics. We can actually test this with the string class. And when we add something, we can add A, B, and so on. And then we could actually print it. We could say print, and it will store that type. And it can store any type, really. It doesn't have to be strings or integers. It could be full objects or whatever you want in that queue, and it'll work. So now that we have this, we can test add back string, and we put this right in here. And so if we were to compile it, let's change the name though. So let's change it to string. So let's recompile it again. And let's run it. And you notice test that back string, printed an A and then a B and so on. So anyway, if you want to see more of this or see me test more things and be more robust about testing, like adding front, adding back, maybe adding iterable or iterator interfaces, just let me know. The link to the code is going to be below the video description. So just if you want to actually grab the code, you can go there to grab it. So thanks for watching. If you like this video, please subscribe. I do appreciate all the subscriptions. If you have any comments or anything, just leave it. You know where to put the comments. So thanks for watching.